We are discussing about the topics system of linear equation and solution of a system of linear equation and different types of system of linear equation. What are the two types of system of linear equation?
Homogeneous and heterogeneous.
Homogeneous and non-homogeneous system of linear equation. And what is homogeneous system?
So we have only one variable.
Only one variable.
Yes, sir.
No, no, no.
No, sir. When total addition of left hand side is equal to 0.
Yes, the right hand side of equal sign. That means
Right hand side.
the constant terms are zero. Then it is homogeneous. And non-homogeneous means at least one of the constant is non-zero. Then it is non-homogeneous system. Then we discussed about how can we represent a system of linear equation in matrix form. Any given system can be represented as Ax equal to B, where A is the coefficient matrix, X is the variable matrix, and B is the matrix of constant types. So next we are going to discuss is what is called a row echelon form of a matrix. Okay. Before that, I will tell you what is called a leading coefficient. Okay, suppose that we are given a matrix A. Then the leading coefficient of a row is the first non-zero entry. The first non-zero entry in that row is called leading coefficient of that row. For example, A equal to 0, 0, 1, 2, 3, 0, 2, 1, 3, 4, 2, 1, 3, 4, 2. Then the first leading coefficient, that means the leading coefficient, the first non-zero entry of the first row, that will be the first leading coefficient. That will be 1. Here the first leading coefficient is 1. And what will be the second leading coefficient? Second leading coefficient means the first non-zero entry in the second row. Here the first non-zero entry is, which one is the first non-zero entry? 2 is the first non-zero entry. So 2 is the second leading coefficient. And from the third row, you can see that which element is the first non-zero entry. That is 2. So again 2 is the third leading coefficient. So another example. What about this matrix? What is the first leading coefficient?
2.
First leading coefficient is 2. Second leading coefficient is
1.
1.
1. And third leading coefficient, which is
1.
1. Right. Okay. So we know what is a leading coefficient of a matrix. So we can move on to what is called a row echelon form. So suppose that we are given a matrix A. That A is said to be in row echelon form if it is satisfying two conditions. First condition is if there is any zero row, it must be at the bottom of the matrix. And the second condition, the leading coefficient in each row must be ahead of the next leading coefficient. Okay, these are the two conditions. First condition is if there is any zero row, that must be at the bottom of the matrix. And the second condition is the leading coefficient in each row must be ahead of the next leading coefficient. For example, suppose A equal to 2134 0000 2121 0123. Is it in Echelon form?
No, sir.
It is not in Echelon form because it doesn't satisfy the first condition. The first condition says if there is any zero row, that must be at the bottom of the matrix. You can see that the second row is, it is a zero row, there is zero row, but it is not at the bottom of the matrix. So it is not in row echelon form. Okay. Consider another example. A equal to what about this matrix? Is it in row echelon form? So we need to check the two conditions. First condition says if there is any zero row, that must be at the bottom. But in this matrix, there is no zero row. So we don't need to check the first condition because no zero row is not there. If there is any zero row, it must be at the bottom. In this matrix, there is no zero row, so we don't need to check the first condition. We need to check only the second condition. So what is the second condition? Second condition says the leading coefficient in each row, it must be ahead of the next leading coefficient. Here you can see that the leading coefficients are, the first leading coefficient is 2 and the second leading coefficient is 2. The first leading coefficient is ahead of the second leading coefficient, right? But the third leading coefficient is 1. So the second leading coefficient is not ahead of the, ahead means it must be in the left side of the next leading coefficient. So the first leading coefficient is ahead of the second leading coefficient, but the second leading coefficient is not ahead of the first leading coefficient. Or we can say like this, look at the position of the first leading coefficient. The position of the first leading coefficient means the column at which the first leading coefficient lies. So the position of the first leading coefficient is 1 because it lies in the first column. And the position of the second leading coefficient, which is 2 because it lies in the second column. And the position of the third leading coefficient. What is the position of the third leading coefficient? It will be 1 because it lies in the first column. So these positions are not in increasing order. If the matrix is in echelon form, the positions of the leading coefficient will be in strictly increasing order. Here the positions are not in increasing order, so this matrix is not in echelon form. What is the reason? It doesn't satisfy the second condition. Second condition says each of the leading coefficient must be ahead of the next leading coefficient. Here the second leading coefficient is not ahead of the third leading coefficient. So it doesn't satisfy the second condition, so it is not in echelon form. Consider another example. Is it in echelon form?
No, sir.
Why? Why it is not in echelon form? Tell me the reason.
So because there are no zeros, and second, the leading coefficients are all same, like in first form.
Uh, what about the first condition? We don't need to check the first condition because there is no zero law.
Yes,
We need
sir.
to, we need to check only the first condition when there is only when there have a zero row. Here here the given matrix doesn't have a zero row, so we don't need to check the first condition. We need to check only the second condition. What is the second condition? Second condition says the leading coefficient in each row must be ahead of the ahead of the next leading coefficient. Here the leading coefficients are first leading coefficient is 1, second leading coefficient is 2, and third leading coefficient is 1. So the positions of first leading coefficient is which comes in first column. So position is 1, and the next one. What is the position? That is also 1, and the third leading coefficient. The position of the third leading coefficient which is also 1. So it will be like positions will be like 1, 1, 1, which is not in increasing order, right? So this matrix is not in echelon form. Okay, what about this one? Is it in echelon form?
Yes, sir.
No, sir.
Why?
Because in second row, instead of zero, there must be a leading coefficient.
No, it is not like that. You can see, you can check the first leading coefficient is 1. Okay. And the second leading coefficient is also 1. And first leading coefficient is actually ahead of the second leading coefficient. It satisfies the condition. It is not
Yes,
necessary
sir.
that
Yes, sir.
it
Yes,
is
sir.
okay. So the third leading coefficient, which is also 1. The position, look at the position of the leading coefficient. 1. The position of second leading coefficient is 3, and the position of the third leading coefficient, which is
Four.
4, which is 1, 3, 4. 1, 3, 4 means it is increasing order. So it is in increasing order. So this matrix is in echelon form. Okay. What about this one?
It is in echelon form.
Yes, it is in echelon form. Okay. So is it in echelon form?
It is in echelon
Yes.
form.
Yes, it is in echelon form. You can see that the leading coefficients, the positions of leading coefficients are 4. What is the position of the second leading coefficient?
6.
6. And the third leading coefficient,
8,
the position is
8.
8. That is 4, 6, 8, which is in increasing order. So this matrix is in echelon form. Also, there is a zero row that is at the bottom of the matrix. So it satisfies the first condition also. So the given matrix is in echelon form. So what about this one? Now is it in echelon form?
No, sir.
No, sir.
Why?
Because condition 1 does not satisfy, sir.
Yes, the condition one says if there is any zero row that must be at the bottom.
Yeah.
So you can see the third row is completely zero. So it is a zero row, but it is not at the bottom of the matrix. So suppose that I am interchanging. What?
There is last row is in 0.
Last row is zero, but the third row is also zero. It is not at the bottom. So suppose I am interchanging this R3 and R4. Okay, I am interchanging R3 and R4. We will get 0, 0, 1, 2, 3, 4, 0, 0, 1, 0, 0, 0, 1, 3, 4, and third row will be 0, 0, 0, 0, 0, 2. Fourth row is completely 0 and fifth row is also completely 0. What about this? Is it in echelon form?
Yeah, yes, sir.
Yes, sir.
Yes, now this is in echelon form. You can see that there are two zero rows and these two zero rows are at the bottom of the matrix, and also it satisfies the second condition also. Look at the leading coefficients. The position of the leading coefficient are in increasing order. This is 3, 4, 6. So it is in increasing order. So this matrix is in echelon form. So next I am going to tell you, if we are given any matrix, we can convert that matrix into raw echelon form. Whatever matrix is given, we can convert this matrix into echelon form using the elementary raw operations. What are elementary raw operations? What are the elementary raw operations?
Exchanging rows and subtracting or adding.
Adding a constant multiple of one row to another row, and also we can multiply a non-zero constant to a particular row. These are the three elementary raw operations. So we are going to use these elementary raw operations to convert a given matrix into raw equation. So that is what we are going to discuss next. So for example, suppose A equal to okay, A is given. I have to reduce this matrix into echelon form. So how will you reduce this A into echelon form? We have to use the elementary raw operations. So what I am going to do is I will mark the first leading coefficient. So what is the first leading coefficient here?
1, sir.
1. So I am going to mark the first leading coefficient. That is 1. Okay. Now I am going to make all the entries vertically down elements as 0 using first row. Okay, because the leading coefficient lies in the first row, so we are going to use the first row to make all the entries vertically down to this one as 0 using some elementary row operations. So I am going to make this 2 minus 2 and 2 as 0 using the first row. So what elementary row operation we can apply in order to make this minus 2 and 2 as 0? We can use only the first row. Okay.
I have
Add.
to multiply by 2 and add in row 3 and subtract in row 3 and add in row 2.
Yeah, we can add the multiple of first row to the second row. So that operation will be looking like this. R2 will changes to R2 plus 2 R1. Okay. Similarly, R3 we can change R3. R3 changes to R3 minus 2 R1. Okay. So these are the operation I am going to apply. So we are using the first row to make all the vertically down elements as 0. So this will be what? What will be our new matrix? There is no change in the first row. First row remains same, that is 1, 2, 3. And R2 changes to R2 plus 2R1. What is R2 plus 2R1? R2 is minus 2, 3, 1. And 2R1. 2R1 is 2, 4, 6. Right. So by adding, we will get 7, 7, 0. That is 0, 7, 7. Right. And what is R3? Our new R3 will be R3 minus 2R1. So R3 is 212 minus 2R1. 2R1 is 246. So by subtracting, we will get 0 minus 3 minus 4. So 0 minus 3 minus 4. Okay. So now we have made all the vertically down elements of the first leading coefficient as 0 using the first row. Now I am going to mark the second leading coefficient. What is the second leading coefficient here?
7.
7. So 7 is the second leading coefficient. And now I am going to make all the entries vertically down to the second leading coefficient as 0 using which row? We will use the second row because the leading coefficient lies in the second row. So we are going to use R2 to make all the entries vertically down to 7 as 0. So what will be the operation?
Multiplies by multiplying 3 in 7, row 2 and uh, multiplying by 7 row 3 and add them.
Yeah, we can multiply R3 with 7 and R2 with 3, and we can add that. So R3 changes to 7 R3 plus 3 R. Right. We can use this.
Excuse me, sir.
Yes.
I have a doubt.
Yeah.
Sir, we won't be changing the first, the row above, the 2 above 7. We won't be changing that to 0.
No, no, no.
Only-
We are only changing the vertically down elements.
Okay.
Okay. We want to convert it into echelon form only. Echelon form means we have to obtain a step like this. Below that step, all the entries must be 0. So I'm going to make the vertically down elements only, not up elements, vertically down elements. So here the operation will be R3. We have to change only R3. R3 changes to what was the operation? 7 R3 plus 3 R2. So now this matrix reduces to, there is no change in R1, that will remain same, that is 1 2 3. The next row will be 0 7 7, and the third row, that will be 0 0. What will be the next element? Minus 4 into 7 plus 3 into 7. So that will be
7.
that is minus 7. 20. Minus 28 plus 21, that is minus 7. So now you can see that this matrix is in echelon form, because the leading coefficients are, the positions of the leading coefficients are in increasing order, 1 2 3. So it is in echelon form. So another example.
Sir,
Yes.
for perfect example of echelon form, we don't have to make all we don't have to satisfy first condition, right?
Which one?
For perfect example of echelon form, we don't have to satisfy first condition. We don't have to satisfy both conditions.
No, no, no. First condition says if there is any zero row, it must be at the bottom. If there is no zero row, we don't have to look at the first condition.
Okay, thank you, sir.
If there is any zero, it must be at the bottom. That is the condition says. If it doesn't have a zero row, we don't have to look at the first condition. We need to only look at the second condition. Okay. Is that clear?
Yes, sir.
So another example, A equal to convert this matrix into echelon form. So like I said, what is the first step? You have to mark the first leading coefficient. Okay. So here the first leading coefficient is 2. Then we have to make all the vertically down elements as 0 using the first one. So I'm going to use R1 to make all the vertically down elements as 0. So what are the operations?
R2 changes to R2 plus
R2 plus, no,
R2.
no, no, R2, not R2 plus R3. Okay, you can use that operation, but I am telling you we are using only R1. Okay, we are changing R2 and R3 using R1.
We have to multiply by 2 all elements of third row and the second row, and subtract third row and the first row, and sorry, second row and first row. Add third row and first row.
We are using the operation R2. R2 changes to 2R2 minus R1. So we are multiplying the second row with the 2, and then subtract the first row from the second row. So 2 into R2 minus R1, that will make this one as 0. And the next operation, that will be R3 equal to 2R3 plus R1. So we are using only R1 to make that element as 0. So this will convert the matrix into 2 1 3 4 2 1 3 4. What will be the next row? Next row is 2R2 minus R1. That is 2R2 means 2 6 4 4 8, and R1 is 2 1 3 4. So by subtracting, we will get 0 5 1 4. So that will be the second row. And what is the third row? Third row changes to 2R3 plus R1. 2R3 is minus 2 4 minus 2 4 8 12, and R1 is 2 1 3 4. So by adding, we will get 0 5 11 16. So that will be the third row. So what is the next step? So we are done with the first row. First leading coefficient. We are finished with the first leading coefficient. That is, we have made all the entries vertically down to the first leading coefficient as 0. Now we will move on to the next leading coefficient. Here the next leading coefficient is 5. So what is the next step? We are going to make all the entries vertically down to this leading coefficient as 0 using which row? We have to use the second row. So we are going to use R2 to make all the entries down to 5 as 0. So what is the operation?
We have to
R3 equals
Okay,
simply
we have
subtract row 2 from row
row,
3.
row 2 from row 2. That is R3. R3 changes to R3 minus R2. So this will reduces to 2 1 3 4 0 5 1 4 0 0 10 12. Now is it in Echelon form?
yes, sir, it is.
Yes, it is in Echelon form. You can see that the leading coefficients, the position of the leading coefficients are in increasing order. Okay. What about this matrix? Is it in Echelon form?
No, sir.
No. So here you can see the leading coefficients are 1. The second row is completely 0. So first of all, we have to
Interchange
interchange.
row 2
Yes,
and row 4.
we have to make that 0 row at the bottom of the matrix, right? So we have to interchange rows. Also there is one more thing. Look at the position of the leading coefficients. The position of the leading coefficients be like 1, sorry, 3, 1, 3, right? So we have to make it in increasing order also. So we have to do two things. We have to make these positions in increasing order, and also we have to make this zero row at the bottom of the matrix. So first of all, I am going to interchange R2 and R4. So the matrix will be 0 0 1 2 3 4 0 0 1 0 0 1
3 to 4.
3 2 4, right? And the third row will be 1 2 0 0 0 0, and the last row that will be full of zeros. Now we have to interchange in such a way that the the positions of the leading coefficients are not in decreasing order. Here you can see that the positions are 3 3 1. So how can we convert this into increasing order?
So
R1 and R3.
by interchanging R1 and R3.
By interchanging R1 and R3. So I am going to interchange R1 and R3. So that will make 1 2 0 0 0 0, and the second row that will be 0 0 1 3 2 4, and third row that will be 0 0 1 2 3 4, and the last row that will be completely 0. Okay. Now what we can say? Is it in echelon form?
No, sir. There is just we have to we have to make 0 in row 3 instead of 1.
Yeah.
Then it will be in
Actually, look at the first leading coefficient. First leading coefficient is 1, and below that leading coefficient all the entries are 0. So we don't need to change that. So move on to the next leading coefficient. Next leading coefficient is 1, and we have to make all the entries vertically down to that 1 as 0. Using the using which row?
second row. Using second row, sir.
Using second row. So what will be the operation?
Have to subtract them.
Yeah. So R3 changes to R3 minus R2. So that will be 1 2 0 0 0 0 0 0 1 3 2 4 0 0 0 minus 1 3 minus 2, which is 1, 4 minus 4 is 0, and the last row is completely 0. Okay, now you can see that it is in echelon form because the positions of the leading coefficients are in increasing order, and also there is a 0 row that is at the bottom of the matrix. So it satisfies both the condition. So the matrix is in echelon form. Okay. So I want to convert this into echelon form. What is the first operation?
We have to multiply row 2 by 2 and subtract from row 1. Yeah, row
Okay.
1.
So that is what we are doing. we will mark the first leading coefficient, right? First leading coefficient is 2, and we have to make all the entries vertically down as 0 using the first row. The operations will be R2, R2 changes to 2 R2 minus R1, and R3 changes to R, okay, R3 changes to 2 R3 minus 3 R2, right? Then only it will become 0, 2 R3 minus 3 R2. But I'm not going to use that. We can do it in a different way. So actually the leading coefficient is 2 here. If I am able to make it as 1, then it will be a lot easier to make all the entries vertically down as 0. So first I am going to do is make it the first leading coefficient as 1. For that I am going to interchange this R1 and R2. Because what is the reason? The first element in R2 is 1. So we can make, if the leading coefficient is 1, we can make all the entries below that as 0 very easy. So to make it the steps easier, I am going to interchange R1 and R2, because there is in R2 the first element is 1. So I am interchanging R1 and R2. Now it made 1, 2, 3, 4, 2, 3, 4, 1, 3, 4 minus 1. Okay, now we can mark the first leading coefficient, which is 1 here. So we can make all the vertically down elements as 0 very easily using some simple operations. R2 equal to R2 minus 2 R1 and R3 equal to R3 minus 3 R1. Right. So this reduces to 1, 2, 3, 4, 0, 3 minus 4, which is minus 1, 4 minus 6, that is minus 2, 1 minus 8, that is minus 7. And the next row, that will be 0, what will be the next element?
Minus 2.
Minus 8.
4 minus 6, 4 minus 6, that is
Minus 2.
minus 2. Okay, next one is minus 1 minus 9, that is minus 10. What is the next one? 2 minus 12, which is minus 10. 2 minus 12, that is minus 10. Now what is the next step? As usual, we will mark the second leading coefficient. Here the first leading coefficient is 1, and we have made all the entries vertically down as 0. Now we will move on to the next leading coefficient, which is minus 1, and we can make all the entries vertically down as 0 using the second row. So what will be the operation?
So I have a question.
Yeah.
What's the need to interchange R1 and R2?
Okay. The first step you have interchanged R1 and R2. That is because in R2 you can see that the first element is 1. So in order to make the first element as 1, the first leading coefficient as 1, I have interchanged R1 and R2. So if the leading coefficient is 1, we can make all the entries vertically down as 0 using some simple steps. Suppose that I am not interchanging R1 and R2. What are the operations? The operations will be R2 equal to R2 R2 minus R1, and R3 equal to, we have to use the operation 2 times R3 minus 3 times R2, 3 times R1. That will be the operations if I am not interchanging R1 and R2. So once I interchanged R1 and R2, the next step is lot easier than the previous ones. Okay, because our leading coefficient is 1, so we can make it as 0 using some simple steps. Here R3 minus 3 R1. Before that, we have to use 2 times R3 minus 3 times R, because the leading coefficient was 2 there. So in order to make the leading coefficient as 1, I have interchanged R1 and R. Okay. You can do it in different ways actually. I just used this step to make it easier. Or you can use in the method that we discussed in the previous example. Okay. Both are same actually. Okay. Have you understood it?
Okay, sir, understood.
Okay. So what is the next step? Mark the second leading coefficient and make the below entries as 0. So the so the uh, so the step will be R3 changes to R3 minus 2R. So the matrix will be 1, 2, 3, 4, 0 minus 1 minus 2 minus 7, 0, 0 minus 6, and the next element that will be 4. So now this matrix is in echelon form. So one thing you have to note down is the echelon form is not unique. It is not unique. We can do it in different ways. And we may get different answers. So the echelon form is not unique. The standard way of converting it into echelon form is, first you have to mark the first leading coefficient and make all the entries vertically down to it as 0 using the first row. Then move on to the second row, mark the second leading coefficient and make all the entries vertically down to this leading coefficient as 0 using the second row, and move on to the third row. Mark the third leading coefficient and make all the entries vertically down as 0. Continue like this until we get what the echelon form of the matrix. Okay, we can discuss more examples on the next class.